Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about comparison of working stress method and limit state method. Methods of design. A reinforced concrete structure must be so designed that it fulfills its intended purpose during its intended lifetime with adequate safety. In terms of strength and stability, adequate serviceability concerning stiffness and durability, reasonable economy. Thus, all structures must be designed to be safe, serviceable, and economical. Reinforced concrete members can be designed by one of the following two methods. Reinforced concrete members can be designed by one of the following two methods. The method of theoretical computations using accepted theories procedures approved by the codes of practice. The method of experimental investigations on models or full-size structures or elements. Commonly used structures are designed by theoretical methods. The following design methods are utilized for the design of reinforced concrete structures elements. The modular ratio method or the working stress method, WSM. The load factor method or the ultimate load method, ULM, and the limit state method, LSM. Working stress method, WSM. This is the traditional method of design, used not only for reinforced concrete but also for structural steel and timber. Close to about 100 years old, the method is based on linear elastic theory or the classical elastic theory. This method of design was evolved around 1900 and was the first theoretical method accepted by stresses are kept well below the ultimate strength of their material. This method ensures adequate safety by suitably restricting the pressure in the materials, i.e., concrete and steel, induced by the expected working loads on the structure. The assumption of linear elastic behavior is deemed justifiable because the specified permissible, or allowable, stresses are kept well below this ultimate strength of their material. The ratio of the yield stress of the steel reinforcement or the cube strength of the concrete into the corresponding permissible or working pressure is usually known as the factor of safety. The WSM utilizes a factor of safety of about 3 with respect to the cube strength of concrete and a factor of safety of about 1.8 with regard to the yield strength of steel. Reinforced concrete is a composite material. The WSM assumes strain compatibility, whereby the strain in the reinforcing steel is assumed to be equal to that in the adjoining concrete to which it is bonded. Consequently, the stress in steel is linearly related to the stress in adjoining concrete by a constant factor, called the modular ratio, defined as the ratio of the modulus of elasticity of steel to that of concrete. The WSM is, therefore, also known as the modular ratio method. Demerits of WSM, disadvantage of working stress method. Most structures designed in accordance with WSM have generally been performing satisfactorily for many years. However, the method has the following demerits. The WSM doesn't show the actual strength nor gives the true factor of safety of this structure under failure. The modular ratio design results in a larger percentage of compression steel than that given by the limit state design, thus leading to uneconomic design. Because of creep and nonlinear stress-strain relationships, concrete does not have a definite modulus of elasticity. Merits of WSM, advantage of working stress method. In spite of the above defects, the WSM has the advantage of its simplicity. Both in theory, in addition to the application. The design generally results in relatively large sections of structural members, compared to the ULM. For this reason, structures designed by WSM give better serviceability performance, i.e., less deflection, less crack width, etc., under working loads. WSM is the only method available when one has to investigate the RC section for service stresses and for the serviceability states of deflection and cracking. It is essential to have a knowledge of WSM since it forms a pan of limit state design, LSD, for a serviceability condition. Limit state method, LSM. We have seen that while the WSM gives a satisfactory performance of the structure at working loads, it is unrealistic at the ultimate state of collapse. Similarly, while the ULM provides a realistic assessment of safety, it does not guarantee satisfactory serviceability requirements at service loads. In the limit state method, a structure is designed for safety against collapse, i.e., for ultimate strength to resist ultimate load, and checked for its serviceability at working loads, thus rendering the structure fit for its intended use. Thus, the LSM includes consideration of a structure at both the working and the ultimate load levels with a view to satisfying the requirements of safety and serviceability. The acceptable limit of safety and serviceability requirements. Before failure occurs, it is called a limit state. A limit state is a state of impending failure, beyond which a structure ceases to perform its intended function satisfactorily, in tenets of either safety or serviceability. I.e., it either collapses or becomes unserviceable. As per IS 456, 2000. All limit states, see 2.5, shall be considered in the design to ensure an adequate degree of serviceability and safety. Difference between working stress method and limit state method. No. Working stress method. Limit state method. 1. Working stress method is also known as the plastic method. Limit state method is also known as the elastic design. 2. Working stress method based on an elastic theory which assumes that steel and concrete are elastic and the stress-strain curve is linear for both. The limit state method is based on the actual stress-strain curves of steel and concrete. For concrete, the stress-strain curve is nonlinear. 3. Within this method, the factor of safety is put on the yield stresses to get permissible stresses. In this method, partial safety factors are applied to get a design worth of stresses. No. Working stress method. Limit state method. 4. In this method, not consider the safety factor. Working loads obtain limit state method. Limit state method are obtained by working loads into partial safety. 5. The exact margin of safety isn't known. The exact margin of safety is known. 6. This method gives more large sections, therefore less economical. This method is more economical since it gives thinner sections. 7. Working stress method is based method of R.C.C design. Limit state method is based method of R.C.C design. Note: working stress method of design definition. Working stress design method is a method said for the reinforced concrete design where concrete is assumed as elastic. Steel and concrete act together elastically where the relationship between loads and stresses is linear. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.